All right, so this is Graphing Quadratics Day 2. It is just practice and review of Graphing Quadratics Day 1. So this first part here is match each equation to its graph. So how I would do it is I would look in the front, look at the A value, and I notice that this one's negative. That means it's a downward facing graph. So I know it has to be either this one or this one. So now I'm going to use the vertex for help. The vertex, this is left 4 and up 6. So I'm looking for a vertex is moved to the left and up. This vertex is not moved to the left and up. This vertex is moved to the left and up. So therefore, I know that that has to go with A. Looking at my next one, I'm looking for an upward facing. So I also need to know my vertex. This is to the left 5 and up 1. So I'm looking for an upward facing parabola. That's to the left 5 and up 1. This is to the left and up, so it has to be this one. All right, next one, I'm looking for a downward. It is to the right 2 and down 2. So B is downward, and it's also right and down. Sorry, not B, this second graph is. That's C. And then obviously by process of elimination, I know what the last one is, but just to double check, it's upward facing, the vertex is 4, 1, so it has to be right and up. Right and up, so this is D. D, C, A, B. All right, number 2, consider the equation y equals negative 3/4 times the quantity of x minus 2 squared plus 8 compared to the graph of y equals x squared. How would it compare to this graph? So first off, does my graph open upward or downward? There's a negative in front, so it is downward. All right, next question. Is the graph wider, narrower, or the same growth as normal? So I'm going to look at this 3/4. Since this is not a 1, it's not the same. That's out. Okay, so the same is out. It's either wider or narrower. So 3/4 is a small number, so the first guess usually people make is narrower. But it's the opposite of that. It's wider. All right, next, how has the graph been translated, shifted compared to the original? So remember, this is going to, let me change colors here. No, to one I haven't used yet, I'll use red. This 2 is going to move it to the right, and this 8 is going to move it up. So I'm going to say it's moved right 2 and up 8. All right, here's another one. Consider the equation y equals 6 times the quantity of x plus 9 squared minus 7, and compare that to y equals x squared. How would this graph have changed? So first off, I want to know, does our graph open upward or downward? If you look, this number is positive, so it is going to open upward. Next, is the graph wider, narrower, or the same growth as normal? I see a 6 in front right here, and 6 is a bigger number, so my first guess is for it to be wider because 6 is a big number, but it's not that. It's the opposite of what I think. It is narrower. Okay, next I want to know, how has the graph been translated? So I'm going to look at the vertex. I can see the vertex, this is moved left 9 and down 7. So I'm going to write that down. Left 9 and down 7. Okay, now we have a function that's already graphed. So we have a quadratic that's already graphed, and it says the graph shown represents the quadratic y equals negative 1/6 times the quantity of x plus 5 squared plus 2. On the same graph, I want to draw roughly where 2 times the quantity of x minus 3 squared minus 4 is. Okay, so I want to draw it in the correct comparison to that graph. Okay, so if you look at this graph, it's downward facing, it's wider because of the 1/6, it's left 5, and it's up 2. All right, so if you look at that's where it is. Okay, so when I draw my graph, I'll draw it in blue here. The 2, well, first off, I want it to be upward facing. The 2 is going to make it narrower, so I want to make sure that I draw something narrower than what's pictured. And then also my vertex is moved right 3 and down 4. So I have to make sure I draw my vertex in the right quadrant. So I'm going to go right 3, down 4. So it has to be somewhere over here. Okay? Right 3, down 4. Next, I said that I wanted it narrower and upward facing. So I want it to be thinner than that graph, and I want it to be facing upward, like so. Okay? All right, the last 4 are all graphing. So remember, when we're graphing a quadratic, the first thing we start with is getting the vertex. The vertex here is 2, 5. So I can start by graphing that, or I can start by filling my table. I'm going to put 2, 5 on my graph paper. All right, now remember, I want 2 values to the right and 2 values to the left, or 2 points to the right and 2 points to the left that I can reflect. So I'm going to go 2 values higher, which are 3 and 4, and then I'll reflect 1 and 0. All right, I'm going to start by plugging in 3. So I have the negative, and then I'm going to plug in 3 inside my parentheses, square it, and add 5. So if I plug in 3, 3 minus 2 is 1. Now remember your order of operations. You have to square this one first, which is 1. Then multiply, so that's -1, and add 5. So I get 4. So when I plug in 3, I get 4. And I also know that when I plug in 1, I'll get 4. I could check if I want. All right, now I'm going to plug in 4. So I have the opposite in front. I'm going to plug 4 into my parentheses, square it, and add 5. If I plug in 4, 4 minus 2 is 2. All right, remember orders of operations. You have to square this 2 first, which is 4. Multiply it by -1, which is -4. And add 5, which is 1. So when I plug in 4, I get 1. When I plug in 0, I will also get 1. All right, now I can graph these points. I'm going to graph the point 3, 4, 1, 4, 0, 1, and 4, 1. This is my downward facing parabola. I'm also going to write the domain and range of my function. If you look from left to right, my parabola goes from an arrow to an arrow, so all real numbers. My range, the lowest my graph goes is an arrow, the highest it goes is a 5. So the lowest is -infinity, the highest is 5, and there's values included, so I'm using a bracket. Also notice I erased the highlighter because it's not part of my graph. All right, next one. What I noticed about B here is that there's no parentheses in it. Remember, when there's no parentheses, you may add them, but you only may add them one place, and that is around X. Okay, so now I'm going to get my vertex. By putting those parentheses, it helps me see that my vertex is at 0, -4. Now I'm going to plug in 2 values bigger than and 2 values less than 0. So 1 and 2, and -1 and -2. All right, plugging in 1, I have 2 times 1 squared minus 4. So remember, you need to orders of operations here. Do your orders of operations. So I'm going to square the 1 first. That's 1. 1 times 2 is 2. And then I need to subtract 4. 2 minus 4 is -2. So I know both of those are -2. Now I'm going to plug in 2. So I have 2 times, I'm plugging in 2, squaring it, and subtracting 4. Make sure you do your orders of operations. Square your 2 first, which is 4. Multiply by 2, which is 8, and then subtract 4, and I get 4. All right, now I'm going to graph my points. I have 0, -4, 1, -2, and -1, -2. And then I have 2, 4, and -2, 4. And there's my upward-facing parabola. All right, next, my domain and range. My X values go from an arrow to an arrow. They go on forever and ever, left and to the right, so that's all real numbers. My range, the lowest my graph goes is -4. Oops. And it's included that value. The highest it goes on forever and ever, so infinity. All right, 2 more left. Next one here, my vertex, -1, -2. 2 values bigger than -1, 0 and 1. 2 values smaller, -2 and -3. I'll start by plugging in 0. So I have 3 times. I'm going to plug in 0 in that parentheses and square it, and then subtract 2. 0 plus 1 is 1. So notice I'm not just putting 0 there. I'm plugging in 0 here. All right, 1 squared is 1. 3 times 1 is 3. Minus 2 is 1. Now I'm going to plug in 1. So I have 3 times. I'm going to plug in 1 into that, and then minus 2. All right, 1 plus 1 is 2. So 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. So just fitting on my graph paper. Okay, so my vertex was -1, -2. And then I have 0, 1. And -2, 1. And then I have 1, 10. And -3, 10. And then I can make my very narrow parabola here. All right, my x values go on forever and ever in both directions. So my domain's all real numbers, -infinity to +infinity. And then my range, the lowest my graph goes is 2. The highest it goes is arrows, so it goes on forever. So that's bracket 2, comma, infinity. All right, the very last problem, notice once again it does not have parentheses. I'm going to put in the parentheses. The only place that I can add them is around x. Okay, so now I can write my vertex here. That is 0, 5. I'm going to plug in 1 and 2 and reflect -1 and -2. All right, plugging in 1, I have -1/2. I have to plug in 1, square it, and add 5. When I plug in 1, I get 1. Okay, so now let's see what this is. 1 squared is 1. 1 times -1/2 is -1/2, and then I have to add 5, which is 4.5. So 4.5 or 4.5, 4.5 or 4.5. Next, I'll plug in 2. So I have -1/2. I'm going to end up plugging in 2, squaring it, and adding 5. Plugging in 2 here, I get 2. All right, 2 squared is 4. 4 times -1/2. So 4 times a negative gives me negative. And then half of 4 is 2. So I have -2 plus 5, which is 3. I'm ready to graph my parabola. 0, 5. 1, 4.5. -1, 4.5. 2, 3. And -2, 3. Connect my points, and there's my wide parabola. My domain, it goes from an arrow to an arrow. It's all x values, so all real numbers. My range, the lowest my graph goes is an arrow, so that's -infinity. And then the highest my graph goes is 5, and it's included there. All right, that's it for today's practice. You can go ahead and get started on the homework.